that's the third chapter, so the title is Circuit Theory. What we have done up to now is circuit variables, circuit elements. Now when we put the elements together, it becomes circuit. So that's the theory. So we're going to introduce, on the base of this theory, we're going to introduce the mathematical model. So in order to do that, we need objective first and the terminology. So those two is going to be just one video. A circuit theory we're going to introduce another video. The third video is going to be mathematical model, and the last one about the conclusions. So altogether there's going to be 4 videos that you could watch. So start from the beginning. What is our objective? Let me read first. By using the mathematical model, linear algebraic equation set of a given circuit, find all the elements, voltages and currents. Without reading the parentheses, just read it once more. By using the mathematical model of a given circuit, find all the elements, voltages and currents. So that means a circuit given to us, and we will be calculating all the currents and voltages of all the elements within this circuit. So when you calculate voltages and currents, that means you can calculate the power of each element, and then you can calculate the energy absorbed by these elements as well. So the mathematical model that we are going to be using is linear algebraic equation sets. So we will see all this in this chapter. So the next thing, in order to reach to that objective, we've got to know the terminology. Terminology is important. Why is that? If you don't know the terminology, that means you cannot understand the rest of the chapter. In the terminology, there are some terms. We will be defining these terms, so definitions comes in. The first definition is circuit. What is get? Anytime when the circuit elements are connected together. We know the circuit elements, so we could put them together by using a simple wire. Once you connect them together somehow, then you're going to get that circuit. Circuit topology, elements connection style. Topology is related with the connections only. Element types, so in order to get a circuit, topology is not enough. You've got to determine what type of elements are connected together. So that means the circuit requires element types and the topology. If the element types and topology is known, then the circuit is known. Given circuit, that is all the element types and their connection is known. That means given a circuit. Circuit analysis, finding all the elements, voltages and currents. Now, related to the topology, there are 2 terminology that we will be using. One of them is nodes. Definition: 2 or more elements connections point. 2 more elements connection point, not connections, connection point. So that means 2 and more elements. One of the terminals of these elements may be connected together. When they connected together, all these elements connection point is called node. Loop. In a given circuit, assume that someone starts from a node and pass through the elements and come back to the starting node. Assuming also that there is no twice passing on an element or node. It is said that the elements pass through make a loop. So what you're doing here, starting for a loop, passing through the elements, go back to the starting point. This is a loop. But there are some conditions on making this loop. These conditions are: you're not going to pass through the same node twice or more, and you're not going to pass the same element twice. So the elements that you pass through makes a loop, we are saying. When we see the examples, we would understand them better. Mesh, any loop which does not include any other loop in it, then this loop is called as mesh. So we will see in the exams, but this mesh business, mesh is a special loop, so you could keep that in your mind. Input, each circuit have a source. Each circuit must have a source, which is called input. So if you've got an electric device, that means if you've got electric circuits, in order to run that electric circuits, you need a power or an input electrical signal. Otherwise, it doesn't work. No energy input, so that means all the elements, current and voltages are zero. So you need input. So power is one of the input. Electrical information included inputs could be another type of input as well. Output, each circuit must have an element of which current and voltage is considered as an output. So all the equipments have got an output. But in general, you can consider the output could be any element's current and voltages. But if you are talking about a specific electrical device, then it must have a specific output. Without output, that means there is no electrical circuit which does a job, no output. Resistive circuit, a circuit which has independent dependent sources and resistors, are called resistor circuits. These are the terminologies that we are going to use in order to set a mathematical model for our circuits. So when we go into the examples, we might understand this better. Now if you look at here now, A and B elements are connected on that node 1. In this it is Turkish, but that should have been English. That's node 1. And node 2, B, C, D elements, the definition of node was 2 or more elements connection point. So this is B, C, D elements connection point. That's this. And if you get D, E, F elements connection point, is just this. But with these, if you consider these small nodes here, it doesn't mean a node in electrical sense. It seems it is 2 here, but according to our definition, these D, E, and F elements are connected on that point. It is just one point, and it is one node only. Seems 2 nodes, but it is just one. If you consider now A, C, E, and F elements are connected here, but it seems the black points here, there are 4 of them, seems 4 nodes. No, because according to our definition, A, C, E, and F elements are connected on that point. So we might consider it like this. So one, the other wire, and the third wire here, just one node. So but it's just one, but it says it is just one. So it might be a bit confusing, but to make it clear, you must keep the definition of the node that we gave before, then it becomes clear. Now in this circuit we've got 4 nodes only, 1, 2, 3, and 4. Don't consider these nodes as separate 4 nodes. When you come to these loops and mesh, so let's start from the meshes first. So this brown one, so we are going to start here from node 1, passing through element A and element F and element D and element B, come back to that node 1. So what we have done, we started from a node and came back to the same node again, and we passed through the elements A, F, D, and B haven't passed the same node twice, and we haven't passed the same element twice. So these elements make a loop. A, F, D, and B make a loop. This loop is that loop 2, the brown one. Another one is the blue one. Blue one, we start from 1 and pass through B, D, E, A, and come back 1 again. So this is loop 1, and in this loop we've got B, D, E, and A elements. There is another loop. I'm not going to show it. You'll find it your own. So let's come to the meshes now. This is another loop, this one. We are starting from node 1, pass element B, pass element C, pass element A, come back to the same node. So this is a loop, but this is a special loop. This is called a mesh. Why is that? Because this loop do not include any other loop in it. That's why it is a mesh. So consider this blue one now. That blue is a loop, we said. This is not a mesh. Why is that? Because this loop has got this loop, mesh 1, and mesh 2, which is another loop. This loop includes 2 other loops in it. So definition of mesh says there should be no loop included in a loop. Then that loop is called mesh. So this is another mesh, and this is another mesh. These red ones do not include any other loop in them, therefore it is called mesh. So in this circuit we've got 3 meshes. These meshes are also loops, and we've got 3 loops. If you ask me, the total number of loops in this circuit is 6. 3 of them meshes, the other 2 of them just loop only. So these are the examples that we could give about the node and mesh business. So this is the end of the terminology. So we mentioned about this objective. For these objectives, the required terminology and definition of all them, and we gave some examples to you. Next, while using this terminology, we are going to introduce you a circuit theory. In this circuit theory, we are going to set up a mathematical model for a given circuit and then tell the conclusions. That is the end of this video.